Hello viewers, welcome to our online lecture. In the last lecture, we had begun with the UV visible spectroscopy. There we discussed about the basic principle of UV visible spectroscopy and how the spectrophotometer works. Now today we will be discussing about the electronic transitions that occur in UV visible spectroscopy. So let's begin. The topics that we will cover today are range of the UV visible radiations, the types of electrons which are present in the molecule, the allowed and forbidden transitions and the possible electronic transitions in UV visible spectroscopy. When we talk about the range of UV visible radiation, it falls under 200 to 400 to 800 nanometers, in which the first range is for the UV radiation, while from 400 to 800 is the visible range. The visible range is that range for which our human eye is sensitive and we observe color. So, the UV radiation is between the microwave and the visible radiation, whereas the visible is between the UV and after that comes the IR radiation. As we have discussed about the range of UV visible radiation, let us also talk about the type of electrons which are present in the molecule. We already know the various theories that we study in chemistry. We know about the molecular orbital theory, and it talks about the different and the covalent type of bonds which are formed in the molecule. So, since a molecule has the ability to form covalent bonds, therefore, these the two major type of electrons which are present in it can be classified accordingly. So, as we know that covalent bonds are of sigma and pi type, therefore, the electrons which are present in a molecule can also be classified as sigma electrons and pi electrons. But as I has already told that in molecular orbital theory, we talk about a category of electron which is known as the non-bonding electrons, or it is also termed as the lone pair electrons. So, therefore, we have three categories of electrons which are present in it, and in the molecular orbital theory, both the categories appear as bonding and anti-bonding orbitals. So, these electrons are also further classified as sigma bonding, comma sigma star, which represents anti-bonding type of electrons. Similarly, pi can also be written as pi bonding and pi anti-bonding, whereas the non-bonding electrons remain as it is. So, in this way, if we talk about the electrons which are present or the electronic levels which are present, the categories, they can be of 5 different types in a molecule. Now, as I am talking about UV visible spectroscopy, we already know that in a molecule, if we talk about the energy levels in the molecule can be, the highest is the electronic levels which are denoted by E, and within each electronic levels there are further subdivisions which are the vibrational levels, and within vibrational levels lie further small subdivisions which are the rotational levels. So, vibrational levels denoted by V and rotational levels denoted by R. So, if I am talking about the spectroscopy, that is UV visible spectroscopy, here it is a radiation of shorter wavelength, and if I am talking about a wavelength of shorter radiation, and I know the relationship of energy E is equal to h nu or E is equal to h c upon lambda. That means energy is inversely proportional to wavelength. Since UV visible radiation is a light of shorter wavelength, therefore it possesses high energy. It has high energy into it. So, this radiation has the ability to cause a transition from one electronic level to another electronic level. Whereas the other radiation that falls after this, that is the IR radiation, is that which has comparatively lesser energy. So when we talk about IR radiation, it has the ability to cause transition, but not of the electronic level. It causes transition in the different vibrational levels, from one vibrational level to another vibrational level. So here we have seen that the type of electrons which are present in the molecule are of 5 types. Now let us see how these different types of electrons, what different transitions are possible in UV visible spectroscopy. Now let us talk about the various possible electronic transitions in UV visible spectroscopy. These are the 5 electronic levels based on the type of electrons that we have just now discussed. So these are the 5 levels, and the axis represents the increasing order of energy, and these 5 levels can be denoted as, the least energy one is the sigma bonding, then pi bonding, non-bonding, pi star or anti-bonding, and sigma star or sigma anti-bonding. So in terms of increasing order of energy, if I talk about, it is sigma, pi bonding, non-bonding, pi anti-bonding, and sigma anti-bonding orbitals. And so possible electronic transitions that can occur on irradiating a molecule by the UV visible radiation are, first possible transition is sigma to sigma star, pi to pi star, n to sigma star, and n to pi star. So we can say that there are 4 possible transitions. And what are these 4 possible transitions that we are talking about? First, sigma to sigma star. We denote it by using an arrow which shows the movement of electron from one level to another. Sigma to sigma star. Then second is n to sigma star. Third is pi to pi star, and fourth is n to pi star. So as I have written the order, it is in terms of the energy which is required. So the highest amount of energy which is required for a transition is sigma to sigma star and n to sigma star. Since these 2 transitions require high amount of energy, so therefore, and obviously we know that when we are talking about sigma transition, it will occur in all those molecules which has a sigma bond, which is there in each and every molecule. And since it is a high energy electronic transition, so therefore we can ignore these 2 type of transition. They are not so much important for a chemist, but when we study the spectroscopic analysis for any molecule, the last 2 transitions, that is the pi to pi star and n to pi star transitions, are the one which are to be focused. So as I am talking about the probability of transition, as it is already mentioned over here, that when we expose a molecule to the ultraviolet radiation or the visible radiation, it is not possible and it is not 100% probability that it will always give rise to a transition. No, all transitions are not possible. Only the 4 which I have mentioned are those which are allowed transitions. So therefore, on the basis of this, we can categorize the transition into 2 types. First is allowed transition and another is forbidden transition. So what do we mean by allowed and forbidden transition? As the term itself suggests, That allowed means anything which can, the process which can take place, and forbidden which the process will not be occurring because of certain constraints and certain reasons. So what is the criteria on which we analyze that this criteria, this type of transition will be allowed and certain transitions will be unallowed in the molecule? So the criteria is on the basis of a value which is known as molar absorption coefficient. As we know that in the last lecture we had discussed about the Beer-Lambert's law, and the Beer-Lambert's law talks about absorbance, and absorbance is a property where we calculate absorption A is equal to epsilon Cl. So this value of epsilon, the molar extinction coefficient, is a factor which determines that a transition is allowed or it is forbidden. So which transition we will consider as allowed transition? All those transitions in which the molar extinction coefficient has the value which falls in the category of 10,000 or more. Its value should be higher than 10,000, then a transition can be considered as allowed transition. So pi to pi star transition that occur in 1,3-butadiene, it has its molar adsorption coefficient value as 21,000. Therefore, it comes under the category of allowed transition, whereas certain transitions are considered as forbidden transition. So as I have already discussed that this categorization is being done on the basis of the value of epsilon, which is molar extinction coefficient. So all those transitions which are forbidden transition have their value of epsilon lesser than 10,000, and all such saturated aldehydes which show absorption, the molecules will absorb in the region of UV visible, but the transition will not occur. So they like for example a simple aldehyde, it has a like which I have shown over here, formaldehyde, it has its molar extinction coefficient value of less than 100, 10 to 100. So it is a very less value, that means it does not show much absorption, and therefore it does not cause a probable allowed transition. Now as I have talked about the two possible transition, let us discuss the most two important transition, that is pi to pi star and n to pi star. As we know, n to pi star transition is the one transition in which the n orbital is involved and its electron is involved in moving from its lower level to the next higher level, that is from non-bonding level to the pi anti-bonding level. Since it has the least amount of energy requirement, and therefore this transition occurs very rapidly in all the molecules which have a non-bonding electron. Now what are the atoms, or what is the criteria on which we can say that a molecule has non-bonding electrons? If I am talking about non-bonding electrons, all those atoms which are considered as heteroatoms, like for example, what are heteroatoms? If I am talking about heteroatoms such as oxygen, sulfur, nitrogen and many more, these are the major ones which are present in most of the molecules. So like in functional groups, acid, alcohol and nitro group, amine group, all those groups have any one of these atoms present in it. And what is the speciality of these? These have lone pair of electrons on them, and due to the presence of these lone pair or the non-bonding electrons which are very easily available for transition, these electrons they absorb energy and immediately they rise to the next higher level, which is the pi anti-bonding orbital. Because when we have discussed about the orbit electronic levels, I had already shown you that the lowest was sigma and pi, and the next higher level to the non-bonding was the pi anti-bonding. So obviously this transition that will occur between n to pi star is the easiest transition that can occur. So, therefore, this is the transition in which the electrons of the unshared electron pair or the heteroatom is excited to the pi antibonding orbital, and this transition involves least amount of energy than all the other transitions which are there in the molecule, and they give rise to the absorption wavelength. Now, the second transition that is considered important into it is the pi to pi star transition. This transition is available in compounds which have unsaturated centers. Obviously, when we are talking about transition from pi to pi star, that means there has to be a pi bond which is present in it. Not necessarily that a heteroatom is present, but a pi bond should be present. So, all the alkenes, aromatic compounds, the carbonyl compounds are all examples in which the pi to pi star transition occur, and the pi to pi star transition shows absorption in what range? In the range of 170 nanometers to 190 nanometers. So, example is saturated ketones. It has an intense band for pi to pi star transition in the range of 150 nanometers. So, here we have discussed about what is the range of UV visible radiation and the different electronic transitions which are possible on irradiating a molecule in UV visible radiation. Now, as I was discussing this, you must have thought that more important criteria in a molecule which we are talking about is the presence of non-bonding electrons or pi electrons. So, that is one of the important application of this spectroscopy, because by using UV visible spectroscopy, we mainly try to find out the presence of conjugation in the molecule, and how we calculate and the presence of conjugation in the molecule will be a topic that we will be dealing in our next video. Hope you must have understood it. Thank you.